All right, this video is going to be on finding inverses of exponential and logarithmic functions. So first example, we're going to have f of x equals 3 to the x plus 1. So if you guys recall, when you are finding the inverse of a function, the very first thing you do is you trade the x and the y value. F of x is just another way of saying y. So the first thing I'm going to do is say x equals 3 to the y plus 1. And then technically at this point we have found the inverse. This is the inverse. But nobody writes inverses that way. People always, when they write something, when they write an equation, they have the y value isolated. They have the y all by itself. So at this point, we need to go through the process of getting y alone. And we do that by doing the order of operations backwards. So the first thing I'm going to try is seeing if there's something that I could easily add or subtract to the other side to get it away from y. I can see it plus 1, but it's trapped in the exponent, so it wouldn't be easy to move to the other side. So I'm going to skip that step. Next, I'm going to see if there's anything I could multiply or divide to the other side. A lot of students would try to divide by 3, but this is a base of an exponent, so I can't get rid of it by dividing. So there's nothing I can do there. The next step has to do with exponents. This is a base of an exponent, so the way that I get rid of it is I log base 3. That is how we do the inverse of the base of an exponent is log base 3. So log base 3 cancels out the base of 3. And then I have log base 3 of x equals y plus 1. Now to get the y alone, I can just go ahead and minus 1. That's not too bad. And so I have log base 3 of x minus 1 equals y. To finish up the problem, I have the y is isolated, but I need my notation to match the beginning of the problem, and I need to show that I have the inverse. So this is f of x, this is y. I'm going to write at the end that I have f inverse of x equals log base 3 of x minus 1. All right, next example. So here I'm going to have y equals 2 to the x plus 3 minus 5. All right, again, first step is to trade the x and y. So first, we're going to see if there's anything we could easily add or subtract to the other side to get the y alone. This time we do have something we could easily move over. It's the 5. Let me go ahead and add 5. So I have x plus 5 equals 2 to the y plus 3. Next, I'm going to see if there's anything I could multiply or divide. Again, students are going to be tempted to divide the 2, but I can't divide the 2. It's a base, and I can't get rid of a base by dividing. So now base of an exponent is I do a log base of 2 and a log base of 2. So now I have log base 2, and the log base 2 was of the x plus 5. It was of that whole group. So I'm going to put that in parentheses to show it happened to the whole thing. Equals y plus 3. And now to get the y alone, I can go ahead and just subtract the 3. Now that subtract 3 doesn't happen to the 5. It happens to that like whole thing. So I'm going to say log base 2 of x plus 5 with a minus 3 on the end equals y. And the y already matches the notation of the original problem. So all I have to do is just stick an inverse on it, and my answer is done. If it makes you uncomfortable that it's backwards, you could go ahead and just switch it around and write it this way and put the y inverse on the left. Okay, so this was starting with an exponential equation. When you start with an exponential equation and find the inverse, it turns into a log equation, okay? So the inverse of an exponential equation is a logarithmic equation. All right, let's move on to our next example. So here are going to be our logarithmic equations. Y equals log base 2 of x plus 4 plus. So again, our very first step is going to be to trade the x and the y. And then we're going to go through the steps. So is there something that I can easily add or subtract to the other side? It's the 1. I can easily subtract a 1 over. Next step, is there something easily that I could multiply or divide to the other side? I can't deal with the 4, it's protected inside here. I can't deal with the 2, it's protected by that log, so the answer is no. 3, there's no exponent, but what I can do, see how this is a base? What I can do is called exponentiating both sides. So this is weird, but if you guys remember, we had over here, we had log base 2 of, this was 2 to the exponent of y plus 3, log base 2. So over here, if I take 2 and I raise it to an exponent, 2 to the x minus 1, 2 to the log base 2. So this is the base, this is the exponent. We have the bases kind of canceling out again. 2 to the log base 2, 2 to the x minus 1. So they cancel out. So I have 2 to the x minus 1 equals y plus 4. So that's actually how you undo a log, is you raise something to an exponent. You add the base of 2, raise it to an exponent. It's called exponentiating both sides. I will not test you on that word. All right, and then at this point, it's pretty easy. You just have to get the y alone, minus 4. So we have 2 to the x minus 1. Oh, my lighting got real dark there. 2 to the x minus 1 with a minus 4 on the end equals y. Again, the notation at the end matches the beginning of the problem. And so we can just go ahead and put a little inverse there, and we are set. All right, we're going to do one last example. So here we have f of x equals 3 times log base 6 of x minus 2. So again, the first step is to trade your x and y. F of x is basically your y. So we're going to say x equals 3 times log base 3 of x minus 2, y minus 2 I mean. So first step is to see if there's anything that you could easily add or subtract to the other side. There's not, there's a minus 2, but you can't get to it. You can't move this 3 because it's multiplied, they're written right next to each other. Next step, is there anything you could easily multiply or divide to the other side? The answer is yes. We can divide by 3. All right, so at this point we have x divided by 3 equals log base 3 of y minus 2. And so here we're going to say, all right, is there an exponent that we could get rid of or introduce? And this is that same step that we did on that last problem where we're going to do what's called exponentiating both sides. So to get rid of a log with a base of 3, we're going to introduce a base of 3. We're going to make an exponential problem. So 3 and the log base 3 cancel out. Now we have a base of 3 to an exponent. So 3 to the x over 3 equals y minus 2. And now I can go ahead and just add the 2 over. So 3 to the x over 3 with a plus 2 on the end equals y. And then I want my notation to match. And so I have f inverse of x equals 3 to the x over 3 plus 2. So what we're going to write now is the inverse of a logarithmic function is an exponential function.